Hi, I'm Henri Drake, a postdoc fellow at Princeton University, and I'm really grateful for this opportunity to share with you some of my research on understanding, predicting, and observing turbulence, mean currents, and tracer transport in the deep sea. So I'm a physical oceanographer, and the tools that I use in my research are geophysical fluid dynamic theory, shown here on the left, and numerical ocean models, illustrated on the right. So I want to sort of work through one example problem that I study, which is what happens to a localized passive tracer anomaly in the ocean's bottom boundary layer. So imagine maybe a sediment plume or an oxygen anomaly, for example. So on the right here is a movie of one such tracer being dispersed and advected around. This is a high resolution numerical model. And then on the left are some equations that describe kind of the average statistics of this flow. And so there's really some synergy between this comprehensive high resolution ocean modeling and these very simple equations. We can use the model to assess the impact of these equations and these fundamental processes on the tracer. And vice versa, the equations help us develop parameterizations to improve and interpret the models. But really, this is a broader collaboration as well, and our groups work with observationalists who go and make in situ measurements of these same processes, and we use those to validate our models and to motivate our theory, and then we use our theory to explain some of the less obvious observations, and we use the observations to our models to interpret these confusing observations. So we're learning a lot about these deep sea flows, and if you think that some of this might be useful in your research, I'd love to collaborate, and please reach out.